Alright, so we start in this video relation functions and graph. And if you don't have a good understanding of the Cartesian plane, you're going to always have problems in relation functions and graphs. So I thought it best to first start with the Cartesian plane, how it works, and so on and so on. So here we have a Cartesian plane. This is the x-axis and the y-axis, the positive side and the positive side. This is the negative side of the x-axis. This is the negative side of the y-axis. Where the two axes meet, it's called the origin. Oh, good. The Cartesian plane has on its axes units. Units that is written based on a scale. We will say that and we have to write it sometimes, that we on the x-axis we're using a scale of 1 centimeter to 1 unit. So every 1 centimeter is 1 unit. 1 centimeter, 1 unit. And that's how it goes. And you can't have a different scale, or you can't have different scale on the same axis. So we say 1 for the x-axis, using 1 centimeter for 1 unit, it has to be on both sides. Then we can say for the y-axis, and this isn't always the case, every 1 centimeter is 2 units, or every 1 centimeter is 5 units. You can say the same for the x-axis. Every 1 centimeter is 5 units. So you count in 5, 10, 15, 20. So, but for this case, we say every 1 centimeter is 2 units. So we say 2, 4, 6, 8. 2, 4, 6, 8, 10. And that is the negative side of the Cartesian plane, or the y-axis. So the first thing we need to know about Cartesian plane is how to plot points. A coordinate is a point, and it is written as, let's say P is X and Y. X is always first, Y is always second. X is always first, Y is always second. So when you're trying to plot a point, you first look for the x-axis, find the number, then look to the y-axis and find the corresponding number. So first example is a is equal to 3 and 5. So 3, x first, y second, always. So this is 3, and we have to find 5. Positive 3, positive 5. So positive 3 here, and positive 5 will be here, in the middle there, between 4 and 6. So this is up there and across there. This coordinate is the coordinate A. It's at positive 3, x first, and positive y second. So now let's look at B. Minus 3 and minus 2. So you have to find minus 3 on the x-axis, that's here, and minus 2. So minus 3 here, and we have to come down to meet minus 2. So this is the point B. It corresponds with minus 3 and minus 2. Then we have C. C is at 1 and minus 6. Positive on the x-axis, come down to minus 6 on the y-axis. This is C. D is at minus 2 and positive 7. Minus 2 on the x-axis, positive 7. That's at the middle there. This is D. Then we have E. E is 4 and 0. 4 on the x-axis and 0 on the y-axis. That is this point on the Cartesian plane. If you notice, if this is 0, the center is 0, if you want to have a y value, you will have to come off of the x-axis. Every place on the Cartesian planes that is off of the x-axis, will give you a y value. But if you're on the x-axis, you will get no y value. Likewise, if you're on the y-axis, f is equal to 0 and minus 4. 0 on the x-axis, minus 4 on the y-axis is f. If you're on the y-axis, you will get no x value, the value is 0. So that's how you plot points on the Cartesian plane. Next thing is the simple linear graph. How do you put x equal to minus 2.5 and y equal to 1.5 and all those stuff on the Cartesian plane? Well, it's called simple linear graph because it's a simple idea. If you look there at x equal to minus 2.5, there's no y value there. So it only has an x value. So it will only go through on the x-axis. So x equal minus 2.5 is a line that goes through the x-axis at minus 2.5 there, and it's completely parallel to the y-axis. This is x equal minus 2.5. Whenever you're drawing a line on the Cartesian plane, you must label the line, and your graph must also be labeled. This should have been written graph of the linear function x equal minus 5. So you write that on the graph paper. Okay, so but I'm trying to do all of this in a short time, so I couldn't write all of that. Next, y is equal to 1.5. So we have to find 1.5 on the y-axis. That's positive. That will be this here. And the line that cuts that point is the line y equal 1.5. And that's how you do simple linear graph. It shouldn't be done on the same graph, people. So please do x equal 3. That is a line that goes through 3 and is completely parallel to the y-axis. And y equal to minus 2. That's a line that goes through minus 2 and is completely parallel to the x-axis. Alright, next we deal with relation. What is a relation? A relation is defined as a set of ordered pair that obeys a particular rule. So, as a pair, it's basically coordinates that follow a particular rule or a set of numbers, if you want to put it that way. So this example is found on page 307, and the relation is x arrow. This can also be written as f of x, or it can also be written as y. F of x is y, function of x is y. So f of x is equal to 3x plus 5, and x is greater than or equal to, we read this from the center, go that way and go back to the center and go this way. X is greater than or equal to minus 2, and x is less than or equal to positive 2. So we have to complete the table below. There is two ways of doing this, and I'll show you both ways. So first way, this is the function. We have to find the y value. The values of x is minus 2, minus 1, 0, 1, and 2, because this says x lies between minus 2 and positive 2. Alright, so we have to find the y value. When x is equal to minus 2, what is the value of y? Well, the value of y, we can say f of x, or y is equal to 3x plus 5. So, but x is minus 2, so this is 3 times minus 2 plus 5. 3 times minus 2 is minus 6 plus 5. And this is minus 1. So when x is minus 2, y is minus 1. And we can find that for when x is minus 1, x is equal to minus 1, y is equal to 3 times minus 1 plus 5. 3 times minus 1 is minus 3 plus 5, and this is equal to 2. So when x is that, minus 1, y is 2. When x is 0, y is 5. How do we know that? Well, if you replace x with 0, 3 times 0 is 0, and just plus 5 would remain. When x is 1, x equal 1, y is equal to 3 times 1 plus 5, which is 3 plus 5, which is 8. So that is 8. So next is, when x is 2, we get y is equal to 3 times 2 plus 5, which is 6 plus 5, which is 11. So this is the first way we can solve individually the values of x. We can find individually the different values of y, or we can put it on this table of value here. The first term in the function f of x is equal to 3x plus 5 is 3x. Yes, we said this is minus 1, 0, 2. This is the first term in the function. So we put that there. We put x, value of x, the first term in the function, and the second term in the function, the 5. But this is constant, so it goes right through. Good. So 3 times x, this is 3x. 3x is 3 times x. So this is 3 times 2 minus 2, which is minus 6. 3 times x, x is minus 1. 3 times minus 1 is minus 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And then we add or subtract coming down. Minus 6 plus 5 is minus 1. Minus 3 plus 5 is 2. 0 plus 5 is 5. This is 8, and this is 11. You can do it on the table. As you can see, it saves you a whole lot of time in the examination. So how do we now put this relation on the Cartesian plane? We learned just now how to put coordinates on the Cartesian plane. This coordinate is x is minus 2 and y is minus 1. I'm sure you can find that. This is minus 1 and 2. This is 0 and 5. This is 1 and 8. This is 2 and 11. Let's see if we can put these coordinates on the Cartesian plane. So when x was 2, minus 2, y was minus 1. So minus 2 and minus 1 is there, because minus 1 is here. When x was minus 1, y was 2. So minus 1 and 2, minus 1 on the x-axis, 2 on the y-axis. 0 on the x-axis, 5. That's there. And 1 and 8, 1 and 8, 2 and 11. So this is my line. So this is my line, and nothing stops on the Cartesian plane. It goes on and on to negative and positive in infinity. So you don't stop the line at the two endpoints there. So then you always have to write f of x or y is equal to 3x plus 5. You always have to label your lines and also your graph. Graph of the function or graph of the relation f of x is equal to 3x plus 5. You need to write it at the top of the graph, people. Okay, also remember that set of ordered pair that we talked about. That will be represented in this diagram here, in that wherever the x is considered as the domain, while the y values is considered as the range. And you will see that one element in the x-axis goes to one element in the y-axis. This is 2, this is 5, this is 8 and 11. So this is a one-to-one relation, because one element is not going to 2, or 2 elements is not going to 1. It's not a many to 1. It's one-to-one, many-to-one, and then there's a relation but not a function, or a function but not a relation, which is a one-to-many. So here you have a next relation, minus 2x minus 3. How do you do that and put that on the Cartesian plane? Well, I'm leaving this for you to do. So pause the video and put this on the Cartesian plane using the x, the domain, x coordinates, and then the range, the y coordinates. And I'm not going to do it, right? So minus 2 times minus 2 is positive 4. Minus 2 times minus 1 is positive 2. Minus 2 times 0 is 0. Minus 2 times 1 is minus 2. And minus 2 times 2 is minus 4. So let's see how this goes. This is positive 1, minus 1, minus 3, minus 5, and minus 7. So I must say to you, and please put this relation on a different Cartesian plane. I just want to draw it there quickly. I must say to you, well, you will see this in the later part of this video. Whenever there's a negative in front of this number here, the x, the coefficient of x, that is the gradient of the straight line, is going to lean this way and not like this one. So let's plot this one quickly. I should tell you that to plot a line, you only need about 2 points alone. You don't need everything there. If you had gotten just 2 of these values from the domain, you can plot the line easily. And let me show you. Minus 2, it was minus 2 and positive 1. So minus 2 and positive 1. This is the first point in the line. And it was minus 1 and positive 1. Minus 1 and minus 1. So minus 1 and minus 1 is here. So this is the line. Okay? You'll see that the line goes this way. And you'll also see that it goes through the other points on the table of value. Let's see if we get 0 and minus 3, 1 and minus 5. 0 and minus 3 exactly there. This is a minus 3. 1 and minus 5 is exactly here as well. So you only needed 2 points. Okay, then you have to label it. Y is equal to minus 2x minus 3. Always have to label and label your graphic as well. Okay, so that is it for... I made a mistake. I didn't... Oh, right. So how do you put anything on the Cartesian plane? You use a table of value, and there's another way, as you'll see in the latter part of these videos. Okay, so we deal with functions now. You don't need a definition for function. All you need to know is to put this function f of x, 3x squared plus 2x minus 5 on the Cartesian plane. We can, as I showed you before, we can do it individually or we can use the table of value. I'm just going to do one individually when x is minus 2. So when x is minus 2, we replace x with minus 2. So this is 3. Yes, 3 replace x with minus 2 square plus 2 replace x with, because you can see there's 2 x's there, 1 and 2, replace x with minus 2 minus 5. So first we have to square it, so this is 3 times 2, minus 2 times minus 2 is positive 4, and 2 times minus 2 is minus 4 minus 5, equal to, this is 12, and these two will give you minus 9, so your answer is 3. So when x is minus 2, y is positive 3. Okay, so let's do the table of value now. So for this one here, you have to replace x with the minus 1, so it's minus 1 square, and then you multiply by 3. Minus 1 square is positive 1 times 3 will give you positive 3. This will give you 12, and this is minus 4, and this is a minus 5. This is the constant, it goes right through. Right. So 2 times minus 1 is minus 2. 3 So what you can do is add the negative numbers and then you subtract, like I did here. I added negative numbers and then I subtract from the positive. So this will give minus 7 plus 3 is minus 4. This is 0, this is 0, the answer is minus 5. This is 1 square is 1 times 3 is 3, and 2 times 1 is 2. So this is, add the positives, you'll get 5 minus 5, 0. And this is 2 squared is 4, and 3 times 4 is 12, as I showed you there. And 2 times 4 is 4. This is 16 minus 5, which gives us 11. Alright, so let's see this on the Cartesian plane. This Cartesian plane is turned this way, so I gotta turn the page. So we have to plot these coordinates. Well, we already saw the coordinates, so let's do this quickly. When x was minus 2, remember you have to label the graph, people, right? Graph of the function f of x is equal to 3x squared plus 2x minus 5. Okay, when x was minus 2, y was positive 3. So minus 2 here and positive 3 there. When x was minus 1, y was minus 4. So minus 1 and minus 4 is here. When x was 0, y was minus 5. So that's there. When x was 1, y was 0. So 1 and 0 is here. When x is positive 2, y is 11. So 2 and 11 is here. You see why it's important to learn how to plot the very first thing we did, because it comes back. So when drawing, this is a quadratic curve. So when drawing a quadratic curve, we don't use a ruler. We have to draw the curve free-handed. So forgive my scrawly drawing if I do it bad. It has to go through here. Right. I think that's fair. Right. So this is the quadratic curve. This is the function. And this is one way in which you put a function, a quadratic curve, on the Cartesian plane. And you have to label it. F of x is equal to 3x squared plus 2x minus 5. And there you go, your quadratic curve. I already worked this out to show that this is a many to one, and I'm going to show you that on the diagram. When x was minus 2, y was 3. Right? When x was minus 2, let me show you again. Minus 2, y was 3. Also, when x was minus 1 and 3/4, 2 or 2/3, minus 1 and 2/3 is somewhere here, y was this here. When x was minus 1, y was minus 1, y was 4. When x was 1/3, see that? 1/3, somewhere there, y is 4 as well. So two values for x end up giving you the minus 4 value. That's why this is a many to one function. Let me show you again. When x was minus, sorry, I made a mistake earlier with this here. When x was minus 1 and 2/3, y is 0. When x is 1, y is 0 as well. So two values for x gives you 0, 1 value for y. That's why this is a many to one. Two values for x, 1 value for y. Many to one function or relation. So let me show you here now. The function f of x is equal to minus 2x squared plus 5x minus 3. Now, because of this negative in front of the x squared, coefficient of x squared, this curve is going to go up and come down. This is what you call a minimum curve. And this is what you will call a maximum curve. And you'll see that later on in these videos. What I'm going to do, I'm just going to pause the video, work this out. You should do it the same. And, then I'll put it on the same Cartesian plane. All right, here we go. So this is 2 minus 2x squared minus 2x squared. So when x is 4, 4 minus 2x squared. When x is 4, 4 squared is 16. 16 times minus 2 is minus 32. When x is 3, 3 squared is 9. 9 times minus 2 is minus 18. When x is minus 2 squared is 4. 4 times minus 2 is minus 8. When x is minus 1, minus 1 squared is positive 1. Positive 1 times minus 2 is minus 2. When x is 0, 0. When x is 1, 1 squared is 1 times minus 2 is minus 2. Then 5 times everything at the top there. 5 times 4 is minus 20. 5 times 3 is minus 15. 5 times 2 is minus 10. 5 times minus 4 minus 3 gives you that. Minus 2 gives you that. 5 times minus 1 gives you minus 5. 5 times 0 is 0 and 5 times 1 is 5. And now we have to do our addition and subtraction here. Just realize this cannot go on this graph. We need a different scale for the y-axis. So I'll put a different graph. So let's get the value. So minus 3 minus 20 and minus 30 will give us minus 55. Minus 3 minus 15 minus 18 will give us minus 36. Minus 3 minus 10 minus 13, and minus 8 is minus 21. Minus 3 minus 5 minus 2 is minus 10. Minus 3. This will give us what? 0. 0. I think we need another coordinate here. 2. Another domain, another value in the domain. 2 squared is 4. And minus 2 is minus 8. 5 twos is 10. Minus 3. What will be the value of y? This is minus 1. Right. So this is interesting. Let's see what this curve will look like. Alright, so when x was minus 4, y was 55, so minus 4 and 55. That's here. When x is minus 3, y is 36, so minus 3 and 36 will be just after 35 there. When x is minus 2, y is minus 21, so minus 2 and minus 21 is just beneath there. You look across there, you see it's just below that. When x is minus 1, y is minus 10, so minus 1 and minus 10 is there. When x is 0, y is minus 3. 0 and minus 3 will be just above the 5 mark there. This is 5. So let's see that's there. When x is minus 1, y is 0. So minus 1 and 0. When x is 2, y is minus 1. So 2 and minus 1 will be just below here. And it goes on and it comes down. Maybe let's see how far 3 will reach. Let's go back to the table of value and see how far 3 will reach. So we have minus 18, positive 15, and minus 3. So this will be 6. 6 minus 6 minus 6. Minus 6 is the answer. So when x is 3, y is minus 6. So that's just below there. So this curve looks like this. And I'm sure it's going to come some. Alright, so this is as I said, whenever the number in front of x squared is negative, it's going to turn up like this. It's going to be a maximum curve. Alright, so this is the first video. Next we go to coordinate geometry.